computation. The common methods for multiplying numbers using pencil and paper require a multiplication table of memorized or consulted products of small numbers. However, one method, the peasant multiplication algorithm, does not. Multiplying numbers to more than a couple of decimal places by hand is tedious and error-prone. Common logarithms were invented to simplify such calculations. The slide rule allowed numbers to be quickly multiplied to about 3 places of accuracy. Beginning in the early 20th century, mechanical calculators, such as the Marchant automated multiplication of up to 10-digit numbers. Modern electronic computers and calculators have greatly reduced the need for multiplication by hand. Historical algorithms. Methods of multiplication were documented in the Egyptian, Greek, Indian and Chinese civilizations. The Ishango bone, dated to about 18,000 to 20,000 BC, hints at a knowledge of multiplication in the Upper Paleolithic era in Central Africa. Egyptians. The Egyptian method of multiplication of integers and fractions, documented in the Ahmes Papyrus, was by successive additions and doubling. For instance, to find the product of 13 and 21, one had to double 21 3 times, obtaining 2 times 21 equals 42, 4 times 21 equals 2 times 42 equals 84, 8 times 21 equals 2 times 84 equals 168. The full product could then be found by adding the appropriate terms found in the doubling sequence. 13 times 21 equals times 21 equals plus equals 21 plus 84 plus 168 equals 273. Babylonians. The Babylonians used a sexagesimal positional number system, analogous to the modern-day decimal system. Thus, Babylonian multiplication was very similar to modern decimal multiplication. Because of the relative difficulty of remembering 60 times 60 different products, Babylonian mathematicians employed multiplication tables. These tables consisted of a list of the first 20 multiples of a certain principal number n, 2n, 20n, followed by the multiples of 10n, 30n, 40n, and 50n. Then to compute any sexagesimal product, say 53n, one only needed to add 50n and 3n computed from the table. Chinese. In the mathematical text Zhoubai Zhuanjing, dated prior to 300 BC, and the 9 chapters on the mathematical art, multiplication calculations were written out in words. Although the early Chinese mathematicians employed rod calculus involving place-value addition, subtraction, multiplication and division, these place-value decimal arithmetic algorithms were introduced by Al-Khwarizmi to Arab countries in the early 9th century. Modern methods. The modern method of multiplication based on the Hindu-Arabic numeral system was first described by Brahmagupta. Brahmagupta gave rules for addition, subtraction, multiplication and division. Henry Burchard Fine, then professor of mathematics at Princeton University, wrote the following: "The Indians are the inventors not only of the positional decimal system itself, but of most of the processes involved in elementary reckoning with the system. Addition and subtraction they performed quite as they are performed nowadays. Multiplication they effected in many ways, ours among them, but division they did cumbrously." Grid method. Grid method. Multiplication of the box method is used in primary schools in England and Wales to help teach an understanding of how multiple-digit multiplication works. An example of multiplying 34 by 13 would be to lay the numbers out in a grid like, and then add the entries. Computer algorithms. The classical method of multiplying two n-digit numbers requires n2 simple multiplications. Multiplication multiplication algorithms have been designed that reduce the computation time considerably when multiplying large numbers. In particular, for very large numbers, methods based on the discrete Fourier transform can reduce the number of simple multiplications to the order of n log 2 log 2 log 2. Multiplication with set theory. The product of non-negative integers can be defined with set theory using cardinal numbers of the Peano axioms. See below how to extend this to multiplying arbitrary integers, and then arbitrary rational numbers. The product of real numbers is defined in terms of products of rational numbers. See construction of the real numbers.